All right. How is everyone this morning? He's good. One guy over here is fine. All right, cool. All right, well, how about a warm welcome for our next speaker, Nicolas Brousse.
No? That's good? Okay. So I will first introduce myself and my company and the environment we work on with all our technology stack, so you have a better understanding of our content and how we try to accomplish our monitoring. Then I will go over our cloud environment and the way we use Nagios for monitoring our servers. So my name is Nicolas Brousse. I previously worked for a couple of industry-leading companies in France. This is why you have this weird accent. It's not the micro. Most of those Oh, good. I'm now working as a lead operation engineer at Tumul. I will talk about Tumul right after that. Globally, I help them to scale their infrastructure. We went, since 2008, we went from 20 servers to over 500 servers. All that on Amazon EC2. We have servers on 4 different regions, and we have some servers on one call center. We are monitoring over 6,000 active service and 1,000 passive checks. We collect over 80,000 Ganglia metrics. Ganglia is really part of our monitoring. We really use it heavily. And we manage over hundreds of terabytes of data with Hadoop, and we do billions of HTTP queries every day. I occasionally contribute to some open source project. I think it's something important when you use open source is that you have to contribute at some point. I don't do anything big, but it's really something that is important to me. Is I have to give back what we take from open source. And yeah, so Tumul has been created in November 2008 by John Hughes and Brett Wilson during their MBA. It was formerly a video analytics and distribution company. We had like a small tracker in video players like Dailymotion, Brightcove, MetaCafe, Vidler, a bunch of them. And we were providing analytics for all those websites. We acquired a company called Illuminex in October 2008. It was a flash analytics company. And based on that, we just built a new product called Playtime. So Tumul became a video marketing company built for branding. So we integrate real-time media buying, ad serving, ad and user targeting, optimization, and brand measurement. So maybe it doesn't talk to anyone here. Globally, Tumul simplifies the delivery of your video ads, and we try to maximize the impact of every dollar spent by brand marketer. When you go on YouTube, you have pre-rolls video. We were one of the first. We were the first one to have videos shown there. So, I mean, we were the first partner to integrate their pre-roll videos. Even if you don't like ads, it's how we make money, actually. So, our environment, it's a little over 10 servers on our Colo Center. We have a few VPS on Linode. I will talk a little more about that, why we have servers there. And over 500 instances on Amazon EC2. And with these instances, it's not like 500 of the same profile. It's not like 500 Apache server. That would be really easy to deal with. But we have like over 50 different profile of instances. So we have like mix of EBS volumes, some server with elastic IP, some other with in 64 bits, some other in 34 bits, 32 bits. And so we had to figure out how to manage all that. And it was part of the complexity of manage this infrastructure. Our technology stack is quite basic nowadays, I think. We use Java, PHP, all the Hadoop suite with HDFS, MapReduce, HBase, Hive. We have some Membase cluster. We have some a bunch of Memcache server, MySQL server, and a lot of other technology. All our monitoring is done with Nagios. Nagios. And yeah, we use NSCA as much as we can. It's something really we try to, especially for all the application level monitoring, like if something behaves in a weird way on the application, when the Java developer that did the application knows better what needs to be monitored. So what we do now is using the, I think it's called JNSCA. It's a Java client for NSCA. So all our Java application just use this client and send directly the information, critical OKR running to our NSCA server. So it offloads a lot of the CPU usage on our monitoring server. And for graphing and trending, we are using Ganglia with a lot of Python plugins. We have still some legacy server using Munin, and I will explain why we stopped using Munin and why we rely a lot on Ganglia now. And for configuration management, yeah, we are using Puppet. We switched to Puppet in last January. Before that, we were managing everything with shell scripting. It was getting really tough. Once you get over like 100 or 200 servers, you just start to cry. So Amazon, I don't know if you know about it. The whole picture is like you have the Amazon EC2 network. You can start server in different regions. What they call region is really geographic region. You have Europe, you have Asia, you have the US East Coast, US West Coast, and inside of this region you have different availability zones. And you can see each availability zone like a different data center in each region. So we have server in different availability zone in different regions, and we are on 4 regions, on the 4 regions that Amazon provide right now. So we like a lot this environment, because we can quickly start new server. We are in a startup environment. We have to move really fast. It's why we switch from an analytics company to ad serving company so fast. It's because we have the ability to just focus on our product instead of trying to plug servers in our rack. So Amazon is very good for that. And we also like it because we can start server in many regions. We don't need to have teams in Europe, even if I would like to be there, but it's really fast for us to start new cluster. We can use different profile of instance. So we have a broad choice like 64-bit, 32-bit, pretty much any Linux version you want to run, you can run it. A lot of RAM configuration and all that. Same thing for the disk. It's really easy to automate because of the really good EC2 API. You can do everything with it. And it's really easy to plug to a configuration management tool. especially since January, we use Ubuntu EC2 AMI. It's become our standard way to manage our infrastructure. Before that, we were trying to build our own AMI, and it requires a lot of maintenance. Each time you want to upgrade the software or something like that, you need to rebuild your AMI, and we don't have time to do that. So what we do now is to rely a lot on this Ubuntu AMI. It's a public official Ubuntu AMI. And the first thing we do when we start is configuring Puppet. And from there, you can do everything you need. The only bad thing, I will say, is like it gets really hard to troubleshoot network failures or any kind of hardware failure. It's kind of a black box sometimes. So you have to be prepared to, in some cases, we just can't troubleshoot correctly what can happen on a server, and it just becomes sometimes easier to just shut down the server and get a new instance, and you will get your problem solved. So it's good and bad, I would say. We occasionally get notified by Amazon after ourselves found some issues on the instance, like you can get some instance that stop responding, losing network, or having really bad disk I/O. And 2 or 3 days after you change your instance, you will get a mail like, oh, be careful, this instance is degraded, you will have to turn it off soon. So it's happened a couple of times. The other problem we had, the other constraint, I will say, is no multicast. It's possible inside their VPC solution, but the basic EC2 way to manage your instance, you will be limited to TCP/IP, to UDP, and ICMP. So when you think about it, it limits a lot of things that you can do. Like you can't use Ganglia in multicast. You will have to set up all that in unicast. So it makes some more complexity in the way you have to monitor your server. And the other bad point is the bandwidth cost between regions. We want to monitor our server in different regions, and we have to pay for bandwidth in and out in each region. So it's not that expensive, but when you are a startup, you try to save any dollar you can anyway. So from there, what we plan to do, we wanted to have like monitoring solutions that is able to scale. We wanted a better graphing trending solution, so we really wanted to switch from Munin. We wanted to automate our configuration, our monitoring configuration. So the question was really how to monitor a cluster. The biggest question was how we monitor servers that we can scale up and down during the day. So we have some cluster of servers. We will have like in the morning we will have like 50 servers, and in the afternoon we'll go to 100 of servers, and then we will scale down that during the night. So how do you monitor that in an efficient way that you know that your application is still up, and if a server is acting weird, you have to figure out that. And the other point was to find a way to change configuration and manage your monitoring configuration in each region in an easy way. We didn't want to log on different servers every time we had a new Nagios alert or something like that. Failure in one region shouldn't impact other monitoring in other regions. That was one of the really important points for us. We didn't want to centralize too much. Because of the environment we were on, we don't have that much control on Amazon. We don't know everything. And we wanted to make sure that if something happened, like a couple of months ago, one of their availability zones completely get messed up. They just did a human error on their EBS switch, and the way they do the failover of their EBS volume, something like that. And it just crashed all their network. All the people in this availability zone got a network connectivity problem, and it lasts for over 10 hours, something like that. So since then, a lot of people are thinking how to quickly move their infrastructure to other VBT zone or region or something like that. But it was really an important point for us is whatever happens somewhere, we want to make sure that our other regions are still up and running, and we get alerts if something's happened on our side. We don't want to be wake up when it doesn't matter. This is something very important. For a long time, we had a lot of alerts for almost everything. I was getting paged at night even for QA testing failing or things like that. As a CSOP engineer, I just don't care when the last build is failing or something like that. So I think it's really important to figure out the good way to alert the right people and on the topics that really concern them. The other big thing is that we have limited resources. We can't spend a lot of money on monitoring, and we are a really small operation team. For over a year, I was alone doing all the operation, and now we are 2 people. So you have to manage your resources in a smart way, I would say. So graphing and trending, it's my first point here because you will see after that we use a lot or graphing and trending for monitoring. What's happened with Munin? You have your Munin server and a bunch of nodes, all your server nodes. And when you want to get an update, update all your RD files and all that on the Munin server, it will just pull each node in a sequential way. So it's good for some time. You can find some tweak to scale it, but at some point when you go over 100 of server, it just doesn't work. It's not efficient. You need a big server to do your monitoring because everything comes from your monitoring server, and it's require a lot of resources. You get trouble with disk I/O, so you have to juggle with a lot of scalability problem. So we looked at Ganglia, and we like it because you have a solution. The gmitad process is pretty much like the Munin update. It will pull the data from a couple of servers, gmod process. But those gmod process get notified by other gmod process. So, oops, sorry. Let me be clear on that. What that means is that on each of our cluster, we can have just one of the nodes acting as a referrer node and get all the data from the whole cluster. And the monitoring server will just pull the data from one of the nodes of the cluster. So on 500 server, we'll just pull 5 servers, which offload a lot of work from the monitoring instance. And you can still escalate all that. You can pull the data from another gmitad process, which can make it really flexible. I mean, you can scale any way you want. So we really like this approach. And here is why. It's pretty much, for me, it's pretty much a pull versus push. Munin servers really fetch the data from Munin client. You can quickly overload the Munin server with disk I/O and CPU. It's collected in a sequential way. So it can really impact the run of your next data collection. So you start to have like some gap in your graph, and you never really know what's going on. For Ganglia, so as I said, you have a representative cluster node, and all your gmod process will send the data to this representative node, and the gmitad will just pull those nodes. It's really lighter on the aggregation side. You kind of guarantee that your data are being collected in a defined interval. And the neat thing to do with Ganglia is that you can also configure each node to say, like, notify me, send information about CPU usage only if there is a variation of 1 or 2. If it's under that, you just don't send the data. So it really tries to limit the amount of data that you will send to your referrer node, representative cluster node, and it's really cool. Yeah. So it's what is called like time threshold and value threshold. So you can, most of the setup we have will be like send data every 20 seconds, if it makes sense, if the value threshold is over like 1, 2, or whatever it is. And we have a time threshold that say, but at least send the data at least every 5 minutes. So we want to make sure to have at least accurate data every 5 minutes. So Ganglia is really designed for a cluster and grid. You can use multiple layers of Gmon, Gmitat process. And you don't need to add manually servers to the configuration. With Munin, you will have to update your configuration for each server so it knows which server it has to pull. With Ganglia, because you have this representative node things, each node that you start will just need to know at which representative node it has to refer. So you don't need to add servers to your configuration. So how did we start monitoring with Nagios? No, we don't use multicast because we can't use multicast. But I'd love to use multicast. So it's one of the problems that we have to make sure we have a bunch of DNS settings to make sure that when we configure Ganglia, it's using the right referrer node. So we will have like mysql.ganglia.private or whatever. That will be your DNS or internal DNS entry. So each configuration file will use that, and it will just send to the right server doing the reference. So here is what we did for monitoring. We have this Linode server. So why we do that? It's really simple. We want to get alerted when we lost a monitoring server on a region. We got many cases for some time where we were losing the monitoring server on Amazon, and we just realized that the next day. So for a whole night, you just don't get any alerts. So like, oh, everything was fine. It's like, great. And it was not. So, and we really want to have something outside of Amazon because we want to make sure that if there is network problem, we can see it too. So it's just basic check ping and check HTTP on the Nagios CGI. So we are pretty much sure that if the Nagios CGI is responding, it's up. And on each availability zone, we have a different Nagios server because we don't pay for network inside an availability zone. So we can have monitoring server in each availability zone without problem. And it has a better latency and things like that. So when you do a basic check ping from this monitoring server, it really makes more sense. So how do we automate our Nagios configuration? So we use, for each Nagios monitoring server, we use Puppet. Puppet will make sure we use regex matching. All our Nagios configuration are based on the regex. So we use heavily DNS to figure out what's going on your infrastructure and try to organize things. So we'll have config files that say all hosts looking like MySQL something. We'll have this kind of alert defined. But we don't use a true regex matching because there is some alerts it's purely tuning for a tuning. Sorry, it's purely for a tuning question. We don't need to have regex for everything, so we just use it when it really looks like a regex. And we configure an SCA with Upstart, just because we are on Ubuntu. I mean, before that, we were using Xinit.da. It was working fine too. It's very basic. We don't use Nagios perf data because we have Ganglia, and we get a lot from Ganglia. So it's really basic the way we manage our configuration file. We just have like 3 directories. And it's all what we have in our Nagios config, actually. We just include every config file that we have in the object, and all the file in servers and cluster. So objects is really basic. It's where we have like all the contact information, time periods, event handlers, commands definition. The servers one, it's where we put config files from every node that we start or removed. So it's a folder that is fully automated. We never touch manually config file in this folder. I will talk a little more about that later. And clusters, it's where we put config file managed by Puppet, and we define per. We have a bunch of alerts defined per cluster. Yeah. So what's happened when we start a new host? We start our instance with a tool that we call Cerveza. We call it this way because the idea was just we start it and we can go for a beer, so nothing else to do. In the fact, it's not that easy, but it was the idea. We use Cloudinit, so most of the setup are done by Cloudinit. It's an open source project by Ubuntu to manage your cloud instance. Cloudinit will set up Puppet on the server, and then Puppet will take care of configuring the Ganglia Gmundi process. The server will start to report to our Ganglia server, to the Gmitad, and we'll start to collect RD files about CPU usage and whatever we set up in Puppet and in Gmund. And what we do is that we have a Nagios check on your server that will just check every minute if there is new host found in Ganglia. And when we find a new host, we just add it to the config file, so in this servers directory, and we just reload the Nagios configuration. So Nagios rebuild itself its configuration based on what it finds in Ganglia. So it makes it really easy for us to manage a lot of server and to handle like scale up and scale down of cluster. Of course, if Nagios just messed up, if our script just messed up something, we do a basic config check before reloading, and if it failed, we just get an alert telling us that the config file are just messed up. And we get recap for this one. So each server configuration file is based from a template. I don't know if you can see well with that, but it's not a Nagios template. It's just a basic template where we put some variables that will just pass with a Perl script and replace. So we will automatically replace the host name, the cluster name, because depending on what Ganglia is reporting, we know in which cluster it's running. We know if it's a MySQL server, if it's a front-end server or whatever, if it's an Hadoop data node, a Hive server or whatever. And we define a bunch of information and a basic check that will just make sure that our DNS entry are right, because we rely a lot on DNS. And we have this, I will talk later about this underscore paging, yes, in the host. It's something that we use just to have better paging alerts on our side. So the Nagios plugin that we call like check TM cluster just go over the RD files, and if a new host is found, it just copies this file and do the string replace and get the new config reload. For most of our alerts, we disable notification. It can seem surprising, but the idea is just like when you have 100 nodes, and for some reason you just messed up a new release, and you start to have a notification for each node, it's just getting awful. And you start to miss important other alert in the middle of that. So you just trash all your email, you stop reading your paging alerts, and you just ignore everything, and you think everything is fine. And during this time, you got another server crashing somewhere else or something like that. So we disable notification, but we have what we call cluster alert. So we monitor the status of the whole cluster. There we go, yeah. And this is an important one because we use status.dat from Nagios, and we go over this status file to get the information of a service. And we just use some basic regular expression to figure out like on which host we need to check and which kind of service name we need to check. So in this case, for example, if we have like 30% of our servers that stop responding to ping correctly, we will get one email with all the hosts in this email that stop responding to ping, which make it like much easier to read and manage. Most of our other checks are based on the RD file from Ganglia. So it's why Ganglia is really important in our monitoring, because we want to limit all the SSH connection or whatever we want to do. We didn't want to add like NRP on the server side. So we already have a daemon running there. It's Ganglia, and it already gave us a lot of information. So we just have a check that is check RRD, and we check whatever RRD file we have coming from Ganglia. And same thing, we can check RRD files and not notify on this check, but notify on the cluster. So in this case, we'll be notified if most of our server stop running space on the /mnt. There we go. So it gives us a lot of flexibility. We have graph for HTTP response time, and based on this graph, we can have specific alerts that will just check the response time for each host and send an alert for the service for the HTTP response time. And we don't need to add like new services, new complex check. We don't have to rewrite a new Nagios plugin or whatever. We already have the check RRD and the check cluster service. So it's really optimize our work and make us much more efficient in the way we want to monitor more new solution or new product we deploy. So with this check cluster plugin, we can check by host and service name, but we can also check by the return message from the Nagios plugin. So it makes it really interesting, especially for the application side when a developer is doing like a specific alert, but he has different error message. So each message will be still a critical alert, but with different errors. And we want to page only on some specific of them. We want still to consider all of those alerts critical, but we want to be paged just on few of those alerts. So in this case, we just, okay, I will just go quickly to this one. We will just use a message filter, and we will just do a regex or whatever we need to filter the alert on the return message. So, yeah, it makes it pretty cool, actually. All right. So we extensively use this check cluster plugin. We limit as much as possible email notification. We use a custom variable called _paging to identify pageable service. One of the problems we had for some time was to use just a normal notification with Nagios. If you use time period or whatever, your contacts are defined to get a notification with a pager or just email. But having both is sometimes difficult. So what we do is just to page only on critical alert for every service or host that has the paging equal yes. So if we don't have that, we will still send emails, critical emails or things like that. We just filter, and in this case, we'll get emails and paging alert. That won't be like halfway. We used different contact and time period, and we really try. This is really the hardest part, actually, because it's not easy to automate. You need to figure out who need to get the right alerts, and this is really the hardest part, to try to avoid to send too much noise to people, because when you start to spam email box, people email box, they just stop reading your emails, they stop reading at Nagios, and you never solve the problem. So it's really the hardest part, try to limit this noise. We use Nagios Checker for Firefox and Chrome. It's a very cool plugin that you can have in your browser, so in Firefox and Chrome. And it's how we configure it just gets its data from the status page from Nagios. And we can monitor all our infrastructure quickly with just this plugin. We know everything. We don't have to go on the Nagios web interface, because when you start to have like 500 servers, a lot of services, it's just getting really awful. And the interesting thing is that with this plugin, you can add your personal filters. So you can say, I just want to see the alert that has not been acknowledged. You can use some regex and say, like, I just want to see the ones that match Hadoop, HDFS, or whatever. I don't want the one from the dev server. So it's really help us in our daily work to just have an overall picture of all our cluster and to understand like what's going on everywhere and what we have to do, what we haven't done yet. So it's really cool. And that's it. We are hiring. We have in San Francisco. Yeah. Okay, cool. Love that. Give me a call. Yeah, everybody is not French in this company, so don't worry. And after 3 years, I got used on my accent, so it's not challenging for them anymore. But indeed, we are hiring for CSOP DevOps, but also QA engineer, salespeople. We have a lot of position open. So that's it. If you have any question.
Oh, let me get you the mic.
Yeah.
Thanks. What parts of your infrastructure do you still co-locate? What parts do you not have on EC2?
That's a good question. So it's few of our servers that are still co-located are the one with our Puppet Master, because we didn't want to rely on Amazon for this part. And all our versioning, all the Puppet configuration are in Subversion, and we have all that on our Colo Center too. We have a series of important MySQL servers there too.
How do you solve connectivity problems? For example, you need connectivity between this part of cluster and this part of cluster. And each server can raise an alert that I can connect to this. And you need somehow aggregate it.
Yeah. So we still have this basic ping check going. This is one of the only active check we have, I think. I mean, we have a bunch of active check, but this is the one that we use to try to figure out if one server has a connectivity problem. it can happen a lot actually on Amazon because not necessarily connectivity problem, but performance in your connectivity. Because you really rely on your neighbor. If you have someone else on the same host running another instance using a lot of network, you will start to have see bad connectivity. And in some cases, we have no other choice to shut down the instance and get a new one. Just find a place where there is not a noisy neighbor.
Well, you're speaking about from connectivity from your Nagios to concrete host, right?
Yeah.
Well, and I'm asking about connectivity from one host to another host. And imagine the case when you need to have connectivity from each host to each host.
Yeah. So what we have in some case, we have some script running on some server doing passive checks, and they will just try to check the specific connectivity. Most of the time that will be a MySQL check. So it will just try the MySQL connection, and it will just send the information to the Nagios through NSCA.
And how are you aggregating this information?
Sorry?
Well, if every server, imagine one server goes down and every other server says that I can't reach him.
Yeah.
And in output, you would like to see something like this server can be reached from whole cluster, not 10 alerts that this can be reached, this can be reached, this can be reached.
Yeah.
Do you have any solution for this?
I'm not sure I understand the problem.
Well, in our case, we have file proxy servers and file server servers. And file proxy should be connected to every file server.
Yeah.
We have a network engineer guys which like to mess things up each weekend.
Seems like a real life experience.
And we want to know about it before users report that they can connect. Well, they implement new SALs, they forgot to implement SALs, and so on. And now we have tons of alert in case one of file servers go down. Nagios knows that the server is down. It's not a SAL issue, but our connectivity check sends the alerts that it can be reached, it can be reached, it can be reached. Well, I thought that maybe you have some idea about how to solve it.
Well, I probably don't have the answer, but in your case, I think we, in this kind of situation, we will use this cluster check where, and most of our cluster check are set up to send us a warning when one host starts to fail. The thing is that it just limits the number of email we'll get. So if on a cluster of 5 servers trying to reach your MySQL server, 4 of them don't have problem to connect, but 1 of them has a problem to connect to the server, we'll get an overall picture of like everything is working except for one server, so the problem is on this server to this other server. So you get a better picture of what's going on. And I think it's the way we will try to answer this problem. Yeah.
Okay, thanks.
Sure.
Did we have any other questions? All right, let's put our hands together for Nicolas. Thank you very much, sir.
Thank you.